All right, so let's go ahead and get started. So we want to cover 7.1 and 7.3 today. So 7.1 you're going to love, okay? Systems of equations, the reason I say you're going to love this one is because you've had this before in Math 101 and Math 102 or previous math classes. So it's actually quite easy, honestly. Okay, so the goal here, you want to, when I have a system of equations, this is where two or more graphs cross each other. It's called a solution. Always write this as a coordinate. So for just a generic system of equations, write it as a coordinate. There's 5 ways that we can do this. The first 3 all are going to be in this section 1, and that's graphing, substitution, and elimination or addition. Hopefully those kind of like ring a bell. Like I go, I've heard those before. Okay, and so and we'll go pretty quickly through those. Number 3, it can either be called elimination or addition, and I'll explain why that's the case as we go through. The 4th one, the RREF, this is all going to be done in the calculator, and this will be in section 7.3. And then the 5th one, Kramer's rule, this will be after the test. This is 7.6. Okay, Kramer's rule will be, but it will be on the final exam. Okay, so it won't be on this test, but it'll be on the final exam because I'll cover that after Thanksgiving. All right, so let's just jump right on into solving by graphing. So when we're solving by graphing, again, keep in mind that a system of equations, this is where 2 graphs cross each other, okay? And so when I'm solving by graphing, I look at the graph, I ask myself, where do these 2 graphs cross over each other? And what would you say to that? -2, 1. Okay, that's all there is to that, literally. Okay, moving on. Now, this does have more instructions, and so I'm going to come back to this question because it says solve by graphing. We did that. Then it says solve analytically. Remind me what analytically means. Showing all of your work. So I want to come back to this one. I want to show my work, but I don't want to do this one immediately, and I'll explain why in a little bit. So let's do solve by substitution. For the record, when it comes to your test, you will have questions that say solve by substitution. And you'll also have questions that say solve by elimination. And then you'll have questions that say solve by reduced row echelon method. And then you'll have questions, not on this test, but on the exam, that says solve by Kramer's rule. Guys, this is 5 ways to solve the same thing, okay? So if I just let you go, you could use like the same method every time. What you need to understand is if I specifically in the direction say solve by such and such, I'm not just looking at your answer, I'm looking at your work. Did you actually do what I asked you to do? Okay, did you use substitution here? Did you use elimination or RREF or Kramer's rule? Okay, so I'll give you some credit for the right answer, but if you didn't use the method I asked for, you're going to lose all of the credit for the work. Okay, which is probably, I would say about 75 to 80% of the credit. Okay, so you get a little bit of credit for the right answer. All right, so solve by substitution. You want to use this method when you have a variable that's either completely alone or almost alone. Like you look at number 2, you've got a variable that is completely alone. And then in number 3, you have 2 variables that are almost alone. It would be really easy to get them alone. Okay, so substitution is how you is when you want to use this is the method you want to use when you have that. Okay, so do you know what y equals? What does y equal? All right then, so what we're going to do is we're going to go to the other equation, we're going to take out y, and we're going to plug in what y equals. Okay, so this is going to be then 2x plus 5y, but I'm not going to write down y. What am I going to write down? 4x minus 6, and then I'm going to finish my equation, which was equals -8. Now, the nice thing about this this equation only has one variable. I can solve for that one variable. Okay, so what will I do to solve for this one variable? What am I distributing? Yeah, so that's going to be 2x plus 20x, okay, and then equals -8. And then what's next? Combine like terms, so you're going to have a 22x is equal to, if you bump that 30 over to the other side, by addition, you'll have 30 minus 8, which is what, 22? So x is what? Are you finished? Okay, now which one should I plug it back into? Why? Because it says y equals, and aren't we trying to find out what y equals? But here's the thing, guys, you can plug it into either one. But I would totally agree with you that the first one is the easier one to plug into. All right, so we've got y equals 4x, but I'm not going to write x. I'm going to write what it equals. Bless you, minus 6. So we've got y is equal to what? -2. Are you done now? Bless you again. What is it? No, I don't have to prove it, although that is a good way to check your work. How would you do that, Devin?
Plug both of the numbers into one of the equations.
Close. Plug both of the numbers into both of the equations. It has to match both of the equations. Let me explain why, Devin, real quick. Think about what this means. It means that I've got two lines that cross each other, right? If I plug a coordinate in and it works for one of the equations, that coordinate might lie on that equation somewhere, on that line. But that doesn't mean it lies on both of them. It has to work for both equations for it to be this one point. Does that make sense? Okay. But you could do that, but that's not what I'm looking for. Go back, say it again. Yeah, write it as a coordinate. You have to write it as a coordinate. I think we have something that says that. Oh yes, always write as a coordinate. So then my solution will be 1, -2. Okay, number 3. Similar concept. The difference here is that it doesn't say y equals or x equals. Okay, so what I would recommend, you actually have 3 variables that are almost alone. Look at the top guy. What could you do to get y by itself on top? Divide by 3, but what would happen when you do that? What would you provide yourself to be required? Fractions. Do you want to work with that? I know you. Okay, so the second equation is actually the better one to get something alone. And I can choose. I can either get the x alone or the y alone. Eating, meeny, mo. Since the y was alone in the last equation, I'm going to get the x alone in this equation. That's the best reason I got for it. Okay, so let's get x alone by subtracting y on both sides. So this is going to be x equals 2 minus y. Or y, negative y plus 2, either one. Now that x is alone, let's go plug in to the other equation. So I'll have 3y. You guys finish that one up. Because this is kind of boring. So you guys finish it up. Now ask each other around you what they got.
Like the coordinate 0 and 2. That's what I got. Would you do? This one.
you guys ask Becca? You finished, Becca? Okay. All right, so let's go through it really quickly then. We've got 3y is equal to 5 times 2 minus y plus 6. So you got 10 minus 5y plus 6. I'm going so fast, this is dangerous. So we got 8y is equal to 16, y equals 2. And then how many equations can you plug back into? 3 different equations. Which one would you choose? What is it you're looking for? What x equals? So I would recommend using the one that says x equals. Okay, but you can use any of the 3. Okay, so we got x is equal to 2 okay, yeah. Right, so my solution then is 0, 2. Okay, Mary Alice, what did you do the first time around? Aha, so you had a 4 there. And so then you got a 1/2. Gotcha. Okay, now let's talk about solving by elimination. I cannot remember, I just was looking at this yesterday, but I can't remember. I can't remember what my lab calls this, okay? So I have seen textbooks call it elimination. That's the more common term, but they might also call it solve by addition. And I want to explain why those two actually mean the same thing. So the goal for elimination is that we want to eliminate a variable. So this is why it's called elimination. Okay. So I want you, don't write anything down. I want you to just follow what I have to say up here. If I were to draw an equation bar underneath these two, notice that all of my variables, all of my like terms are lining up. If you were to add your x's together, what would you get? 15x. If you were to add your y's together, what would you get? 4y, and then you could also add your constants together. But my question is, when I added those together, and by the way, adding them together, this is why it's also called solve by addition, okay? If I add them together, have I eliminated any variables? No, I haven't, okay? So what I want to do is I want to manipulate one or both of the equations so that I can eliminate a variable, okay? So which variable would you like to eliminate, the x's or the y's? X's, and how will you go about doing that? How will you manipulate? Multiply the whole top equation by 2, by -2. So what is that going to become then, that first equation? -10x, so that's where the elimination is going to come in, right? Keep going. Minus 14y equals -12. I'll just go ahead and copy my second equation. So 10x minus 3y is equal to 46. And now when I add, my x's are going to eliminate each other, which gets me down to one variable. One variable is something I can use to solve. So x's eliminate. What do you get for y's? -17y is equal to, on the constants, 34. So divide on both sides by -17 and y equals -2. You finished? No, you need an x value, don't you? How many different equations are there to plug this y value into? There's 3. You have the 2 originals, right? And then you've got the manipulated version of that first equation. So of those 3, and I'll call this one the first one, the second one, and the third one, which would you choose? The first equation, the second equation, or the third equation? Abigail, why would you choose the first one? The small, yeah, exactly. The numbers are smaller. And we all know that the bigger our numbers, the more chances we have of making careless mistakes, right? So we've got 5x plus 7y, but now I know my y is a -2 is equal to 6. So that'll be 5x minus 14 equals 6. 5x is 20. So x is 4. Am I finished? No, put it in a coordinate. It always frustrates me when I'm grading this test and the number of times I have said, write a coordinate, write a coordinate, write a coordinate, write a coordinate, and a student still says x equals 4, y equals -2, and I have to take off points for that. I'm like, seriously? How many times did I say that in class? All right, so that was solving by elimination. I want to go back up to that example 1 where we had to solve this analytically. And I want to give you the choice, and I want you to back up your choice. Would you rather solve this, by the way, spoiler alert, we already know what the answer is because we've already seen it on the graph, okay? But would you rather choose this, choose to solve by addition or solve by substitution? Solve by elimination or solve by substitution? Why? Yeah, when you add them together, you already have an elimination. So let's go ahead then and use elimination. X's eliminate. What do you have for Y's? Equals. So Y is not a shock. Okay. And then what do you want to plug that back into? The first one or the second one? How come? No negatives, I'm good with that. All right, so you've got x plus 1 equals -1, so therefore x is equal to -2. And again, we knew what the answer was going to be, so it's not a surprise. So sometimes I will give you the choice. I'll let you solve any way that you want to solve, okay? Example number 5. Example number 5 is still under the elimination section. Okay, so let's go ahead and use elimination. So talk to me about what you would like to do to be able to eliminate something. Multiply the top one by 3. Okay, we'll talk about that. Mm-hmm. It sure will. It sure will. So let's go ahead and see what we're going to do with this, okay? Because this one's going to end up a weird one, okay? We're okay with weird, okay? We're all weird in some way. So what do you have for your first manipulated equation? Okay, and on the other one, I'll just copy 9x minus 6y is equal to positive 30. When you add, what do you get on the left? 0. When you add, what do you get on the right? 0. Now my question is this a true statement? Yes. Now it's a weird statement because it doesn't say x equals or y equals. It doesn't tell us anything at all about solving, okay? So here's the deal, okay? Let me come over to some itchy paper here, just some blank paper. We already know that 2 lines could cross each other, and this is my one solution, right? We already know that that can happen. We've seen it happen. Another option is that 2 lines could be parallel to each other. And in this case, where are my solutions? There aren't any, right? Because a solution is where 2 graphs cross each other. These guys never cross each other, okay? So we would say here, there's one solution, but here, there's no solutions, okay? And the reason there's no solution is that the lines are parallel. But then there's a third option, okay? There's a third option. What if I have a line, and then when I go graph the other line, it's right there. It's the same line. How many solutions are there now? There's an infinite number of solutions. And the reason there's an infinite number of solutions is because they're the same line. Now, here's the thing. This guy, are these ever gonna be equal to each other? No, they will never equal to each other no matter how many values you try. They're never gonna equal each other. How about these two? Are these guys ever gonna equal each other? Well, yeah, like always. They're always equal to each other, right? Okay, so then let's come back over to my weird. Are these two ever equal to each other? Well, yeah, like they're always gonna be equal to each other, right? No matter what, they are always equal to each other. So there's a couple of ways that we can write this, okay? So first of all, how many solutions are there going to be? Okay, so we'll say, actually it's not all real numbers, but it is an infinite number of solutions. Devin, the reason it's not all real numbers is that this coordinate right here is not a solution, even though it's included in all real numbers. Does that make sense? But there are, because it's not on my line, okay? But there are an infinite number of solutions. So here we've got an infinite number of solutions. They're the same line. Okay, and I want to explain to you how my lab requires you to give this answer. Okay, me personally, I'm totally fine with this as my final answer. Okay, but my lab isn't. So let's talk about, how does my lab want you to answer this question? It still wants you to answer the question with a coordinate. Okay, so the coordinate is going to be something y. Okay, which means I need an x value. So what you'll do is you'll go solve for x. Solve one of the equations for x. Okay, now which equation would you rather solve for x? The first one or the second one? They're the same line, it doesn't matter, right? So we'll pick the first one. The numbers are a little bit smaller, okay? So let's pick the first one. So we'll come over here, we've got negative 3x plus 2y equals negative 10. So if I'm getting x alone, what will I do to get x alone? Okay, so that'll be a negative 10 minus 2y is equal to negative 3x. And then divide both sides by a negative 3. Now, can we clean up that right-hand side a little bit? Yeah, it would be all positive because you have every single term is negative. Okay, and so my brain just got stuck. If you reduce this fraction, neg over neg is pos, and if you reduce this fraction, neg over neg is pos. Okay, so that's the easiest way to say it. So we'll have a 10 minus a 2y divided by 3, and that's actually what my lab requires you to type in for the x value. It's not. Thanks. So that's the coordinate that my lab will ask you for. But ultimately, in English, this means, hey, these two are the same line. I have an infinite number of solutions here because those two lines cross at every one of their points. Okay, me and my dumminess, number 6, we actually just did. I forgot that I wrote it down here. This is number 6. Okay, I am not working the same question twice. Well, oh, wait, I already have. I am not working the same question a third time. Okay, so let's get number 6. Let's go to number 7. It does say to solve analytically, which means you get to solve it any way you want to. Okay. So why don't you guys go ahead and do this one on your own? Pick a method. You can use substitution, you can use elimination. What method did you use? Elimination. And how did you manipulate? Which one? Okay, so we're going to multiply by -2. Is that what everybody did? Devin, what'd you do?
I started to do that, but then I changed my mind.
Okay, that's fine. So how did you change, what did you change your mind to?
Well, I started doing substitution.
Uh-huh.
I just not.
Okay, gotcha. All right, so then new equation here is -6x minus 4y equals -10. 6x plus 4y equals 8. So what do you find? What happens? What do you get down there? Now, when was the last time that was a true statement? Never. So these two numbers are never going to equal each other. So therefore, I also know my two lines are never going to equal each other. So, so we would say there's no solutions, which you just told me. Why are there no solutions? They're parallel. All right. I think this is a fraction here, y over 5. You're all excited because we're working with fractions, right? Now I've taught you how to get rid of fractions. Okay, so if I've taught you how to get rid of fractions, how could I go about doing that? Multiply everything by the common denominator. Now, right now, I'm not even worried about substitution or elimination. Let me just make these guys pretty so I can figure out what I want to do with them. Okay, because I don't want those fractions in there. So we'll multiply everything by the common denominator. In this case, that's 5. So what does your first equation, first term become? And the next term? Equals 155. So the trade-off, at least when I work with fractions, I get smaller numbers, but if I get rid of fractions, I'm usually gonna have larger numbers. That's the trade-off, okay? But that's okay. We can do the same thing since my common denominator is a 5 here as well. So what is my first equation, sorry, first term gonna become? 10x, and then minus y equals 40. And this is what I'm going to use for my system of equations. Since I'm given the choice on this one, it didn't say I had to use substitution or elimination. Since I'm given the choice, what would you guys choose? Substitution, and what would you do to start your substitution? Okay, so you're gonna isolate the x in the first equation. I'm good with that. So we've got x is equal to 155 minus 15y. Okay, so then let's take that x equals and plug it into the other equation. So that'll be 10 times, not x, but 10 times 155 minus 15y. And then I still have my minus y equals 40. So because this is tens, that's not so bad. What's 10 times 155? Yeah, it's 155 with a 0 on the end, right? So minus the next piece, 150y minus y equals 40. What will your two y's become? Negative 151. I'm going to go ahead and move that to the right. That negative 151y, I'm going to move it to the right. So that'll be a positive 151y. And then I'll take my 40 and move it to the left by subtraction. So 1550 minus 40 should be 1510. Because 50 minus 40 is 10. Are we good? Then what? It's going to be y equals 10. We finished? No. Okay. How many equations, this one's a tricky question. How many equations can you plug this value back into? 1, 2, 3, 4. Yeah, 5 of them. Which one do you want to use? The one with x equals? And did somebody else say something different? Yeah. So I would have chosen either this one, except that the numbers are really big, but it's not going to be so bad because it's a 10. So 155 minus 150, right? That one won't be so bad. Or I would have chosen this one. I like Mary Alice's idea because 10 divided by 5 is 2. So I get to work with smaller numbers here. Okay. Either one is going to be fine. Let's see, if we have 2x minus 10 over 5 equals 8, that'll be 2x minus 2 equals 8. 2x equals 10, so x is 5. And hopefully you already kind of did that mental math over here. 155 minus 150 is also 5. So what's my solution then? 5, 10. That one wasn't that bad. I mean, there was fractions involved, but it wasn't that horrible. Okay. Well, if we're going to just talk horrible, let's just go ahead and keep on, right? So what's your idea? Like, I don't even care right now about substitution or elimination. Okay, let's just clean these guys up. How can I clean up the first guy? Multiply by 10. Yep, the common denominator is 10. Now be careful when you do this. When you take a 10 and multiply it by the first term, what's going to cancel? What will you get when you cancel? Yeah, you'll get the 10 and the 5 will cancel and it'll leave you with a 2. But you also have that x plus 6 up there. Okay, so don't forget about the 2 is what I'm trying to convey here. So I've got a 2. I also have an x plus 6. So what is that going to become? 2x plus 12. Now, what cancels when I pass to the next term? Both the 10s, what's left? Yeah, and it's a plus 2y minus x. By the way, can I stop you right here? Because here, can I point out a really common mistake? If this had been a minus sign, when you cancel the 10s, what would be left? Yeah, but what would I write over here? Negative 2y plus x, because that negative would need to be distributed to both of those terms. Okay, so just be aware that that could totally happen, and that's a very common mistake. Like, students will tell me the first piece is negative, but they forget about the second piece being negative. Okay, go ahead and pass through the third guy, and you get what? Equals 10. Now, this is a prettier equation, but it's not cleaned up. Okay, so let's go ahead then and do one more step to clean it up. So how would you write this? Yes, but we went ahead and moved the 12 to the right and combined it with the 10. Okay, so that's totally an equation worth working with. Okay, way better than this. Okay, all right, so what should we do to the second equation to clean it up? Multiply by, say it again, 20. Okay, so pass to the first term. 5x plus 10. Your 20 and your 4 are going to reduce to a 5, and you want to pass the 5 to the x and the 2. Okay, pass to the next term. Yep, your 20 and your 5 reduces to a 4. So you want to pass your 4 to the 3y and the 2. And that's going to equal negative 60. Prettier since I don't have fractions, but not pretty enough. Thoughts? Let's clean up. What do you get when you clean it up? Negative 78. Okay, so now's the time when it's good to decide, okay, what method do I want to use? All right, so I'll ask you, what method do you want to use? Substitution, you want to get x by itself? What other method could I use pretty easily? How? Yeah, so I mean, it would be really easy to multiply the top equation by -5, and that would eliminate my x's, right? Which one's better? Eeny, meeny, miny, moe. Okay, now you guys all chose substitution, so I'm gonna let you run. Go do substitution, I'm gonna do elimination, okay? So that means like you could follow what I'm doing, but it's not gonna do you any good. We should get the same thing at the end. Do we? Mary Alice, you didn't get this? So when you did substitution, and you did 5 times -2 minus 2y plus 12y equals -78, what did you get for x there? Or for y there, excuse me. That first, when you did substitution? You did do substitution, right?
Yeah.
Yes, so, and you got x alone. And then you plugged x into the other equation. You got y equals what?
So I plugged it into the 5x plus 12y equals -78.
Yep,
So I plugged in x equals -2 minus 2y.
yep. And you distributed the 5? Uh-huh. And what did you get when you distributed the 5? What's that whole line?
-10 minus 10y plus 12y equals -78.
Now you guys have the work. I don't have the work in front of me. So far, so good? Okay, so now we're gonna combine like terms. There's a light bulb. So what did you do wrong then?
I didn't combine, or yeah, I accidentally combined the 10 and the 12 instead of, or dropped off to wild and
Gotcha. Okay. All right. Well, that's okay. Your brain just grew a little bit. So it was nobody else's brain in here grew because they didn't make a mistake. Yours did. So congrats to you. You were the winner on this one. All right. So, but Mary Alice, those small mistakes can make a difference. Okay. So be careful about those. All right. So, let's do a story problem. And I think this is going to be the last question for this section. I forgot about this question. So this semester, Mr. Hart's a little hard up, so she's going to sell some grades. She sells a total of 293 test grades. And she sells 93 more A's than B's. So the first thing that we're supposed to do is we're supposed to write a system of equations whose solution is going to give the number of A's and the number of B's sold. Okay, now the first thing I'm going to tell you about story problems. Don't go back to your old X's and Y's. Use letters that make sense. What would the letters be that would make sense here? A's and B's. Okay, now we have to write a system of equations, which means we have to have two equations. Okay, two or more, but there's only two unknowns, so we'll have two equations. So let's go back and reread that, okay, and let's see if we can figure out one of our equations. So Ms. Roberts is going to sell grades. Okay, great, that's fine, but there's nothing in that, okay? Let's go to the next one. She sells a total of 293 test grades. A total of 293 test grades. Now, how could I write a total of 293 test grades? Okay, but that's not a full equation. Say it again. Yeah, my number of A's plus my number of B's gives me a total of 293. Okay, good. So that'll be our first equation. So this is going to be part A. A's plus B's equals 293. Okay, let's go to the second part of that statement. She sells 93 more A's than B's. She sells 93 more A's than B's. Now, first of all, what operation do we feel like we might be using? She sells 93 more A's than B's. Addition, okay. And so what kind of an addition equation could we set up?
93 A's plus B.
So you used addition and multiplying? So, okay. When you get stuck like this, use numbers that make sense. Okay? So let's change the problem for a minute. Let's say she sold 2 more A's than B's. Let's make it easier. Let's say she sold 1 more A than B's. Okay? How could I write that? And by the way, there's nothing in there that talks about the 293.
Could you do 293 minus the A's equals B?
Mm-hmm.
B plus 93.
Yeah, so if I just said B plus 1 equals A's, would that be 1 more A than B? Okay, so play with numbers that are smaller, that make more sense if you get stuck, all right? So if I said, so I'm gonna write 2 different things here. Let's see if we can figure it out, okay? First thing I'm gonna write is the wrong thing, so don't write this down. B equals 93 plus the number of A's. Why is that not right? What am I going to have more of? So if I take my number of A's and I add 93 to them to get the number of B's, I'll have more B's. But I don't want more B's. This says I sold more A's, right? So let's trade the A and the B. Now if I take my number of B's and add 90, even if I only had one B and added 93 to it, I would have more A's. Okay, and so this tells me then, okay, I really did sell more A's than I sold B's. Okay, so that's part A. Just simply write the equations. Part B, solve. Okay, so I would ask you, would you want to use substitution or elimination? Definitely, you've got a variable alone. Okay, so let's take that A equals and plug it into the first equation. So instead of writing an A down, what will I write? Okay, so a 93 plus B is what I wrote. And then the rest of the equation, plus B equals 293. So then combining like terms, my B's make 2B, or not to be. Move my 93 to the other side, and what do I get? 200. So B equals 100. Have I solved the equation, or solved the system, excuse me? No, so I'm not done yet. Okay, so then let's go get A. How about let's use the A equals. So A equals 93 plus 100. So A is 193. Now, a lot of students will stop here. I know we still have to do part C, but a lot of students will stop here and they won't ever check to see, does this make sense? Okay, so let's go back and reread the question with our new numbers here, and let's see if it makes sense. She sells a total of 293. Okay, so we've got, here's B, we have here's A. Does that make sense? Is this a total of 293? Yes, it is. And then it says she sells 93 more A's. Does that make sense? Did she sell 93 more A's? Yes, so I'm checking my answers to make sure that it makes sense, okay? Oh, so many times, like I'll ask the question, how many children and how many adults? And somebody will say there were 4.5 children. How do you get a half of a child? Explain that to me, okay? Like, well, yeah, okay. Anyway, so make sure that your answer makes sense with the question. Now we still have to do part C. Here's the thing. I told you that you're always, when it's a generic system of equations, you're always going to write your answer as a coordinate. But this is not a generic system. This was a story problem. So instead of writing a coordinate for your answer, I'm going to ask you to do part C. Interpret the solution. What does this mean? And a lot of times it's going to require that you write out a little statement. Okay? So my interpretation says what? Exactly. Now let me talk about why I make you do an interpretation. A's and B's, that one was really easy to figure out what letters you guys were going to use. But what if I had said something about we are selling hot dogs and hamburgers? What are your two variables going to be? See, you could all choose something different, right? So like maybe some of you would use a capital H and a lowercase h. Or maybe some of you would choose the second letter, and so you would talk about O's and A's, okay? I don't know what you're going to choose, and so that's why an interpretation, since everybody could use a different set of variables that's not quite so obvious, the interpretation tells me exactly what you found, and it doesn't, I don't have to know what variables you're using. I don't care about that. I just want to know, what does this question mean, okay? All right, any questions about that? All right.